My name is Rohan Desai, and I'm here with Epic. Frank is a patient being treated in the ICU when he experiences an acute change in mental status. As a provider in the ICU, to diagnose this issue, we will order an MRI to be completed by Hyperfine. As we sign the order, an HL7 version 2 order message is sent from Qvera, who will route the order to Hyperfine. The next step in the patient's care is for the radiology technician to perform the MRI. But first, we will hear from Qvera about how the order reaches Hyperfine.
I'm Brandon with Qvera, and I'm an interface engineer here for Qvera, so Qvera Interface Engine. As mentioned, the HL7v2 message was sent from Epic to Qvera. We then take information from that HL7 and we store that information for the modality, forklift. Now, a modality or imaging machine you cannot push data to it. What you end up doing is it ends up querying, so you have to store that data. So we store that data. Then in this case, the Hyperfine swoop machine is able to query the Qvera using the DIMSI modality worklist query, and we're able to bring that order information back up, send that to the machine. What this sends is the demographics as well as all the order information as well, so that we have everything there. This allows the clinician or the X-ray tech, whoever is doing the work, to go to the machine, query for the list of orders and thing there, and get a list. So that all the demographics and all that is on the machine and ready to go for them. They do not have to manually enter it. They just have to verify it's the right patient. What this does is it reduces the clinician's time, as well as improves accuracy because they're not manually typing something in on whatever interface that particular modality has. Now that we've got that working, or we have received that order, we'll now turn it over to Hyperfine, who is with the machine.
Hi, my name is Sean Doyle. I'm a software engineer at Hyperfine. And on the modality work list, you can see that the patient information's arrived. And like any modality device, we can select the patients off the list to get the demographics and ordering information. So if you could select that. This is going to, if the device was really here, as opposed to like having a simulator, it would take about 20 to 25 minutes to acquire the DWI, FLAIR, and ADC sequences. Once they've been acquired, we send them to Brain Insight, which is a cloud-based solution that Hyperfine has, where we run inference on these on the images, looking in this case for stroke lesions. With this particular study, there's going to be a lesion in the right occipital lobe of the patient. When that inference is done in the cloud using the AI algorithm, we're going to read the results down to within the hospital, and then we send them with DICOM to the PACS. Here, Qvera is our PACS, and we're going to send both the image information and DICOM structure reports. This fits in with the IHE AI results profile. And the structure report contains annotations for the images, as well as the coded findings for the lesion that was discovered as well. After that, the images are just sent to Qvera, and I'll turn it back over to Qvera.
As you mentioned, we received those DICOM images via the DIMSI protocol. We received the structure report as well as the other images. We do that via the DIMSI protocol, which a lot of newer applications don't support. So we're able to receive those images via the DIMSI protocol and send them to a local PACS using that same DIMSI protocol for archiving, documentation type purposes. We also send a copy of those to Lifomic. Lifomic is a newer application, does not support DIMSI. They support a newer protocol called DICOM Web. So we're able to send those same images to Lifomic using the DICOM Web protocol. And we send that including the structured report. The other thing we're able to do is with the structured report, we're able to extract from that the diagnoses and some information that's been put in there, and to put that into an HL7 message, ORU message to send to Epic. What that will do is close the order in Epic, but on top of that, it will also send that information that's in that structured report over to Epic, so that that's part of the patient's chart without someone having to manually enter that information. It just is sent there. The other thing we do is we send an alert so that the clinician knows that this is completed, that the images have been taken, it's been analyzed, and the results are back in Epic. And with that, we'll turn it back over to Epic.
When Qvera sends in the MRI results via HL7 version 2, they also send Epic a WCTP XML alert message to notify Frank provider. The notification message from Qvera appears as a pop-up on the bottom right of my screen, so I'm aware that Frank's results are ready to review as soon as they come in. This allows me as a provider to focus on other issues while waiting for the MRI to be performed, without worrying about delaying Frank's care. Opening up Frank's chart, we can review the findings from the MRI and make decisions on how to move forward with Frank's treatment. To view the images of the MRI, we can launch into another application, Lithomic, utilizing a Smart On Fire launch. This launch provides both the provider credentials and patient information to Lithomic, streamlining the process for providers, reducing clicks and time spent logging into other systems. As the ICU provider, I will now continue into Lithomic.
I'm Matt Lavin from Lithomic, and I'm continuing the role of a clinician looking at MRIs. The Lithomic platform has collected DICOM data via Qvera and has also collected patient information from Epic via Smart On Fire launch. And I'm going to open up the DICOM browser. So here you see a patient UI configured for Frank, and you can see that I've switched over to see the DICOM studies, and you can see here that there's a single study list, one with a basic viewer. So I'm going to open up the view from the past here. I'm going to look and scroll down to the bottom, and I want to show the structured report, which was included in the DICOM images. So this is the structured report that Hyperfine's AI is generating and adding to each of the images. If I open it up, you can see in the DICOM viewer that Hyperfine has marked certain segments of each of the slices with a marking to say that a lesion was detected. This would give you the full power of browsing DICOM images in a way that you're used to, such as the 4x4 grid. And the Lithomic platform is really built for any medical device to store data and give a more detailed view to clinicians. So in this case, we've configured the demo for the DICOM browsing, but if this was a different company, say tracking diabetics, then you might collect data from CGMs and show a history of glucose or insulin rather than DICOM images. So what we've demoed today is a series of protocol integrations between 4 different companies and hopefully saving time from the clinician.